So students, what's the first question or what's the question? Derive an expression for the magnetic dipole moment of a revolving electron. Students, I will explain what is magnetic dipole moment. Already we have explained in the last topic, magnetic field due to electric current. But still again I will explain what is magnetic dipole moment. But before that, let me concentrate on the word that is what revolving electron. So students, as we know, if I consider positive nucleus, okay, around the positive nucleus, electron is what revolving. Suppose electron is revolving in anti-clockwise direction. Okay, as we know, when electron is revolving in anti-clockwise direction, then direction of current will be what? Clockwise, because it is what? Conventional current, conventional direction of the current. Okay, when electron is revolving in a circular orbit, definitely let radius be smaller. Okay, so what is smaller? Smaller be the radius of the orbit. Linear velocity, small v, associated with what? A revolving electron. When electron is revolving, v stands for what? Linear velocity. So let me write down here. R is what? Radius of the orbit. Okay. V is linear speed or linear velocity of electron. E is charge on the electron. Okay. Chalo. Students, if all those things we know, one more thing I will let me tell you. M. What is small m? M is the mass of the electron. M is the mass of the electron. Okay. So students, from this information we can write or we can write down angular momentum. What is the angular momentum? Already we have done in the topic called atom, molecules, nuclei. What is symbol of angular momentum? L. Okay. What is the formula for L? mvr. याद होगा तो mass into velocity into radius. Okay. Remember this formula. Okay. Now students, due to the motion of or circular motion of electron, current is flowing. Okay. What is general formula for current? What is general formula for current? Current is what? Rate of change of charge. Okay. Rate of change of charge. Okay. So what is the charge over here? Charge means what? Charge of current upon time. Okay. What is T here? T stands for time required to complete one revolution. That is called period. Okay. Time required to complete one revolution. Matlab, I want to tell you, when electron completes one circular motion, so what is the time required to complete one circular motion? That is called capital T. And what is the current associated with that particular revolution is what? I. Okay. Students, when electron is revolving, okay, it completes one revolution. So will you say formula for time is what? What is velocity ka formula? What is the formula for velocity? Velocity is what? Distance upon time. Distance upon time. So what is time equals to? Distance upon what? Velocity. Okay, but distance what? Distance covered in one revolution. Okay, distance covered in one revolution. So how much distance is covered or we can say carried out by the electron in one revolution? That is what? Circumference of circle. And what is the velocity we consider here? V. So students, now we know the value of T. What I will do? I will put this T in this equation. Which equation? Equation number 1. So now I will put equation number 1 and 2. Don't worry, student, I will explain it again. Those who have joined late, I will I will explain. Okay. So now I'm going to put the value of T in equation number 1. So this is what third point. So what is current? Equation becomes E upon capital T is what, students? 2 pi R upon V. Okay. Now in the next step, this V will come in the numerator. V E into V upon what? 2 pi R. Okay. Say this is the equation number 3. Now you are asking, sir, what is the question? Question is what? Derive the expression for magnetic dipole moment. and you are writing the equation of current, you are finding the expression for period, and then you are putting into the formula of I. But what we need, magnetic dipole moment. What is the symbol of magnetic dipole moment? Capital M. Why you are finding this A? Because now the main thing will come. Magnetic dipole moment is given by which formula? Magnetic dipole moment. You know the formula we have done already in the last topic. Moment, magnetic dipole moment. What is the formula? Symbol is M. Formula is what? I into A. If you remember, last time we used the formula for NIA. N is number of turns, I is what? Current, and A is what? Area. But here number of turns, because this electron is what? Revolving only one complete circle. Okay, that's why we take N is 1. So what is the magnetic dipole moment? I into A. That's why we need I. We did too much mathematics because we want I. Now we will put a value of I. What is I we have now? I का value कितना है? E V upon what? 2 pi R. Multiply by A means what? Area of this particular circle. What is area of circle? Pi R square. What we observe, students? We observe that 1 R get cancelled. 1 pi get cancelled. So what is the remaining term? EVR upon 2. So this is the formula for magnetic dipole moment. But students, one more mathematics I am going to do over here, because in the syllabus they have done like this. What they have done like this? They keep E as it is. They keep 2 as it is. Means what? E upon 2 they have taken first. Then VR they have taken what? For a distance they kept. Okay. What exactly I am going to do? Students, simple thing they have done. They multiply and divide by what? M. They multiply and divide by M. Now question is what? Why they have done like this? Because M into V into R, already we know. What is L into M into V into R, which is L. So what is the formula, final formula? E into L upon 2M. So this is the final formula of the magnetic dipole moment. There are two formulas. Two formulas means what? If information about E, V, R are given, then apply this formula. If information about angular momentum, mass and E are given, then apply this formula. So there are two formulas of magnetic dipole moment. Okay. Hope so you understood. Please copy.